Hello. In the lecture series of cognitive ergonomics, today I am going to talk about working memory capacity. Working memory capacity refers to how much information an individual can process and store it at the same time. Higher the capacity, does it reflect high intelligence or does it reflect more attentional control? This can be subjective in nature. We do not know about this thing. However, one thing is very clear, that more information an individual can process, more time he can save this information. He requires more time to store this information. With repeated practice, with more experience, it may eventually help him or her to have better intelligence than the other. Not the high intelligence, but it can be little better than the others. Attention definitely plays a major role here. That is why Denman and Carpenter devised a unique method to access the working memory. How do people process the information and how do people store the information? So, they proposed the processing task where an individual has to read a comprehension, and then there is a recall task which ensures and reflects upon the storage capacity. If you have stored the information, your recall will be better. You can recall more amount of information. So, processing task, reading span, the largest number of sentences, reading a comprehension an individual has to do. And at the end, individual is asked final words. Person is asked to recall the words used in the comprehension, which suggest the storage capacity. Moreover, the operation task, working memory we are just talking about, is involving the arithmetic problem along with the recall of the words. So, if an operation, an individual has to perform an operation, this operation is going, arithmetic operation is going to interfere with the recall task. So, such interference reflects upon the, not only the interference but also reflects upon how much information a person has registered, encoded and stored in working memory. Moving forward, it is very important for us to understand the human factor implications of working memory limits. Working memory, when we were talking earlier in previous lecture, it has 4 components, and these 4 components all together help us in the execution, in decision making, in reasoning, in problem solving. What we have to do, we have to minimize the working memory load. Minimizing the working memory load, one can consider an example of typing a password, typing a computer password or login password of your mobile phone, or several accounts of journal publication which one is handling. How one can remember these passwords? If you can minimize this workload, then the remembrance will be better. For better remembrance, alphanumeric password is better than only numbers or alphabet alone, which means if you combine the letters along with numbers, it is easy to remember. Such as if somebody is having a name Asha, date of birth 1992. Then first four letters like Asha can be taken and the year of birth 1992 combined together. Asha 1992. Easy to remember. Instead, only remembering Asha and adding a surname to it or any other thing. Providing visual echoes. Providing visual echoes provides visual aids, such as for the navigation, people use visual cues. For the navigation, several signs and symbols are visible to us. When you go to a museum, there are wayfinding cues are there, which provide you assistance. These visual echoes assist and also predicts the working memory limits. Based on our working memory limit, we can use these visual cues, echoes. Providing placeholder for a sequential task. A sequential task is similar like maximizing a bottom-up processing in perceptual system. Maximizing a bottom-up processing, maximizing a sequential task. A task which requires 4 steps or 5 steps, 3 steps. It is easy to remember this. As you can see in this cartoon, there is a visual information, but as the sunset is setting down, as the night comes in, auditory cue is provided as well. Or if you see on your right hand side the cartoon where a person has to work from top key to bottom key, remembrance, sequential task is important. Which button need to be pressed more often should be placed at bottom level. The buttons which has to be used rarely should be placed at the top, should be away from the reach. The proximity between the two buttons, the mental proximity and the physical proximity. In order to remember huge list of words, we have to think about chunking. Physical chunk size, meaningful sequencing, how we are sequencing the task, superiority of letters over numbers. We have biasness towards letters, alphabets over the numbers. Keeping numbers separate from the letters. Chunking is a common practice. Using chunking, we register information of our friends' phone number, acquaintances, family members, etc. Sequential task. A child, when he has to dress up, what are the sequence, in what sequence he has to wear the clothes, how he can dress up. These 8 stages reflects upon the meaningful sequence, what has to be done. From individual to individual, these sequences may vary. Or remembering a number plate, registering a number plate. Alphanumeric has an advantage over the others. Alphanumeric also provide detailed information, such as you can see on your screen, WB indicates the state, West Bengal. 74 indicate the city code, the district code, followed by the car number, which is C5602. It is equally important for us to minimize the confusibility. Confusion should be minimal. If more confusion will be there, then one may be not able to execute the task. Avoiding necessary zeros. As you can see on your number plate, two types of number plates are there. Which number plate can minimize the confusibility? One is linear and another is in vertical form. The state and district is different from the car number. While in the previous nameplate, district, state, district and car number is on the same line. In first case, it is one row, while in the second, there are two different rows are there, 2 rows and 4 columns. Another example, avoiding unnecessary zeros. Necessary zeros are not required. Like here, 3 examples are there. One writes 0, 0, 0, 0, 3, 4, 5 is GNT. Another person writes 3, 4, 5 GNT. 0 has significance when it is followed by a number or a letter. But if 0 is not being followed by a letter or number, then it increases the confusibility. Consider working memory limit in the instruction. A person has to throw a ball. There is a preparation, there is an execution, and then he has to take an action towards it. So, working memory limits in the instruction. How much information one can register, how much information one can recall, the type of information one can register, the type of information one can recall. So, what you see on this cartoon reflects upon the integration of working memory, peripheral working memory, the memory of memory, getting input from the knowledge base, which is prior saved information from prior experience, through similarity matching, frequency gambling, direct search, and after that there is an output to it. The integration of several levels such as sensory information, when it is coming, it is sending information to this peripheral working memory system or a focal working memory system. Parallelly, this information also reaches your knowledge base system. Sensory input is trying to see if you are having a prior knowledge about the concept or idea or the stimulus or not. If you are having a prior knowledge, then it will not wait for the focal memory system to give the input. It will directly execute the task. Directly. This becomes a short route. However, when sensory input has searched the knowledge base, it doesn't find any information, then it tries to inquire. It doesn't inquire. It checks the focal working memory, it checks the peripheral working memory. This system is receiving input from your stored information system, and this is checking for similarity. Do I have similar information present in my system? Do I have a similar frequency, or I am not looking for similarity, looking for frequency, but I am doing a direct search? Does this information exist in this knowledge system or not? If it exists, then it sends the information to focal memory, and from focal memory then information comes back to the output. So, you can see this can be a short route, and this where sensory input is going to focal memory, then focal memory is checking with knowledge, and then again it is coming back to focal memory, and then it is coming out as a output. This is a long route. So there is a short route and there is a long route. Now, when we talk about such system, working memory, it is important for us to see the knowledge base which we are referring to as long term memory. This long knowledge base system, how does it store information? So we have a multi-store model which we discussed in previous lecture. Here sensory store is there. If we pay attention to it, it moves information to short term memory, which we refer it as working memory in human factor design or ergonomics or cognitive ergonomics. The information which we do not pay attention to short term memory, we forget, but if we do the rehearsal, we go to sleep, then it moves into our long term memory storage. Long term memory is defined as a place for storing large amount of information for indefinite period of time. What do we understand with indefinite period of time is that it could be days, it could be weeks, it could be months, it could be years, it could be decades, it could be century if we live. Working memory capacity 50,000 to 1 lakh words. Arithmetic facts, historical facts, geographical, political information. Not only that, coding, semantically similar words are difficult to learn compared to acoustically similar words, such as we are having word list 1 and word list 2. Now, in the word list 2, what do we see? Huge, big, great. They are semantically similar. It is very difficult to remember this list compared to the list 1. With the similar words are there: mad, map, man. Why such difficulty is there in our long term memory? Because of interference. Because you are storing the information for long period of time and semantically similar words compete with each other. It becomes very difficult to register such kind of information for long period of time, unless and until you do a rehearsal. Long term memory has large capacity, is having coding. This coding can be based on auditory system, visual system, or any other type of sensory system. Storage is big. Upon retrieval, it becomes soft. If nothing is being done, it gets stored again. Rehearsal plays more role. More and more you do the rehearsal, capacity will increase, coding will get enhanced, storage will increase, retrieval will be better upon more and more rehearsal. Long term memory generally being divided into 2 different parts. In human factor ergonomics, if we talk about, cognitive ergonomics we talk about, or psychology we talk about, there are 2 different types of long term memory: implicit and explicit. Implicit means non-declarative memory. Indirectly we are learning about the information, storing information. Declarative, explicitly. Explicitly is divided into 2 parts: episodic and semantic. The word itself, episode, means an event in an individual life. Semanticity means the meaning to it. Non-declarative memory is an indirect form of learning, which is priming, procedural learning, associative learning, sometimes fear conditioning we also call it, and non-associative learning, which is sensitization, habituation. So in these types of long-term memory, one form of memory which we are going to pay more attention to is the declarative type, explicit memory, which is having 2 parts, 2 components: semantic memory and episodic memory. Because in cognitive ergonomics, these 2 types of memory are playing a major role. Implicit memory we do not pay attention to. We do use them We do use them for the storage, for the executive processing. However, these two different types of memory, semantic and episodic, seems to have a more relevance and importance in cognitive ergonomics. Semantic memory relates to the meaning of the words and concepts, the rules which we are using. Episodic memory refers to the events. For instance, a child remembers about the apple, what apple is, what characteristic apple is having. It is edible, it is fruit, it is juicy, it is red in color, it grows in Himachal Pradesh. Episodic memory about the episode, about the event. I went to the apple garden with my friends on this and this date, on this occasion. That is an episode. The day you graduated, the day you got married, the day your parents celebrated 25th anniversary. All those are episodes, which plays an important role in one's life and functions as a sort of autobiographical reserve. Now let us closely look into the features of long-term memory. First feature is a strength, and second is the association. If we talk about the strength of what? Strength of long-term memory. How robust that memory is. The strength of memory depends upon how frequently you are using it. If you are frequently using the password of your computer, you will remember it robustly. Nothing can modify, manipulate that. No cognitive processes can interfere that. How recently you have used it? Have you used it today at this moment, or you are using it after 20 days or 30 days? If there is a gap, in the usage, then it impacts the recollection. Have you done any rehearsal? Have you done any practice? So practice and rehearsal seems to have an effect in the strength of long-term memory. When we talk about the association, we see different professions are listed here. We associate the profession with the person. We associate the profession with the characteristics. How a labor will look like, how a construction worker will look like, how a welder will look like, how an engineer will look like. The cues related and associated with construction worker, the cues related to the welder, the cues related to the engineer. This is an association. Because of our easiness, because of human cognition, to provide simplicity, to provide easiness, we learn and store information based on association. To conclude what we studied in this lecture, we studied about the working memory capacity. To understand the working memory capacity, we have a processing task and a storage task. Reading span is there, digit span is there, which help us in understanding the capacity of working memory. There are 7 factors related to working memory which defines its limit. We also studied the long-term memory and the type of long-term memory. There are 2 different types of long-term memory: declarative, non-declarative. Declarative has 2 types, non-declarative has 4 types. But we tried to put emphasis upon two declarative forms of memory, that is episodic and semantic memory. And finally, we concluded with the features of long-term memory, that is the strength and the association of memory. With this we finish this lecture, and in next lecture we will start with attention. Thank you.